Good morning, student. Today we start the class with the topic interference. So it is very important in this chapter. So in this chapter, in this topic, that is in the interference, there are 5 marks for theory question or 5 marks for the problem. So we have to concentrate more on this topic in this chapter, that is interference. So what is interference? That is the modification in the distribution of light energy when two or more light waves superimpose. So this phenomenon we call as interference. So what is interference? So interference is the modification in the distribution of light energy, the modification in the distribution of light energy when two or more light waves superpose, then the phenomenon we call as interference. So interference is the modification in the distribution, that is one wave overlaps with the another wave, then its intensity either may decrease or it may be increase or it may be decrease. So that modification, that phenomenon is called as interference. So this one is the definition for the interference, that is the modification in the distribution of light energy when two or more light waves superpose on each other. So here the light energy is taken in as intensities. We studied the light energy here in as intensities. So intensity of the light waves. So that is the definition is the modification in the distribution of light energy when two or more light waves superpose on each other. So that phenomenon we call as interference. So here we studied the interference based on one principle, that is superposition principle. So what's the superposition principle states? So superposition principle states that the resultant displacement of number of waves, that is the resultant displacement produced by the number of the waves, is the vector sum of the displacement produced by each of the wave. That one called the superposition principle. So what is the superposition principle? The superposition principle states that the resultant displacement produced by number of waves is the vector sum of displacement produced by each of the wave. So this is the statement of the superposition principle. So what the superposition principle states that the resultant displacement which is produced by the number of waves, either it may be 2 waves or 3 waves or more than 2 waves, there we get one resultant displacement. That displacement is equals to the vector sum. So here we have to consider that is vector sum of the displacement produced by each of the wave. That is the individual displacement produced by the single waves. So if we consider this one is the wave, right? So this wave produces the displacement, that is y1, and if we consider another wave, So for this wave, the displacement produced by the wave is y2. Then the resultant displacement of these two waves can be written as the resultant displacement y, that is equals to vector sum of the individual displacement of these two waves, that is y1 plus y2. So this is the statement of the superposition principle. So here the intensities of the individual waves either may increase or either it may be decrease. So by using the superposition principle, we are going to discuss the topic, the interference. So we have to remember the superposition principle statement, that is the resultant of the displacement produced by the number of waves is equals to the vector sum of the displacement produced by each of the wave. So if we consider for one wave, it is y1, for second wave it is y2, and if we take two more waves, that is y3 and y4, then the resultant displacement becomes y1 plus y2 plus y3. So this is for the next considering wave. Up to n number of waves we are going to consider, then it becomes yn. So here y is the displacement of the resultant wave. After all this, we get the resultant displacement either this, then it becomes y. So here y is the resultant displacement. Now we study the interference by using the superposition principle by considering few cases, right? So first we know that what is interference. That is the redistribution of the light energy when two or more waves superpose, that is overlaps on one another, then we get the interference. The principle of superposition states that the resultant displacement is equals to the vector sum of the individual displacement produced by the each waves, right? So here consider two sources. So considering this one as the source 1, and after a certain distance considering another source S2, right? So S1 and the source S2. Considering one point P somewhere in the medium. So if this is one medium, in that medium we are considering one point P. Considering the distance from S1 to P is equals to the distance S to P, that is the distance S1P is equals to S to P. From this point, these two sources are at the same distance. So sources means here the wavefronts are generating, that is source which emanates the wavefronts or waves, right? Like this. So these two sources are at the same distance from point P, then the time taken to reach these wavefronts at point P is same. So from source S1 the wavefronts takes 5 seconds to reach the point P, then the source from S2 is also take 5 seconds to reach the point P. That is the time taken from these two sources is same. That is the wavefronts to reach the source is same. If the source S1 producing the wavefronts are in phase, then the source S2 producing also in phase. Here the wavefronts which are receiving at the point P is also the waves are in phase. That is, it has constant phase difference, right? So if I draw like this, right? So here from S1 the wavefronts are emanating and reaches the point P. Similarly from the source S2 also emanating the wavefronts and reaches the point P. If these two sources are in phase, then the resulting wavefronts which are received at the point P also the wavefronts are in phase, right? If we write the displacement for the source S1, that is the displacement of the wave produced by the source S1, that is displacement of S1, that is displacement of the wave produced by S1, that is we can write y1 is equals to a cos omega t. Here it is a wave. Here I am considering the wavefront, or we can consider it as the wave. So if we consider this one as the wave, then the wave equation is a cos omega t. Here a is the amplitude of the wave, right? So similarly, the displacement produced by the wave S2, that is the source S2, we can write y2 is equals to a cos omega t. So what the superposition principle states that at any point P in the medium, the resultant displacement, that is the resultant displacement which the wavefronts received at the point P can be written as y is equals to y1 plus y2. That is the vector sum of the two waves, that is the waves which are produced from S1 and the waves which are produced from S2. We have y1 is equals to a cos omega t, y2 is equals to a cos omega t, because these two are same, because these are vibrating in phase. So vibrating in phase means S1 and S2 produces the same waves, hence the displacement is also same, and these two displacement, that is the waves reaches the point P in the same time, then these two are equal. So if you write here, the value of y1 is a cos omega t plus a cos omega t. Here we get the resultant displacement y is equals to 2a cos omega t. That is the resultant displacement, that is these two wavefronts superimposed, and we get that at the point P is y is equals to 2a cos omega t, right? So we know the intensity is proportional to the square of the amplitude. Then if we write the intensity for the wave 1, that is I naught is equals to, that is the intensity is proportional to the square of the amplitude. So here A is the amplitude, then square of the amplitude is A square. That is the intensity of the wave y1, that is the displacement y1, the intensity of the first wave is I naught is equals to A square. Here it is also said y1 is equals to y2, then here also the intensity can be written I naught is equals to A square, right? So here I is the intensity. So if we write the intensity of the resultant displacement for y, then I is equals to square of the amplitude. Square of the amplitude is 2a whole square, then it becomes 4a square, right? Square of the amplitude is, here the amplitude is 2a, then it becomes 2a whole square, it becomes 4a square. So in case of a square, we can write I naught, that is the resultant amplitude I is equals to 4 I naught. That is the intensity is 4 times of the individual intensity of the wave. So if the two wave sources are producing the wavefronts which are in phase, then the sources are called as coherent source. Coherent source. So what is coherent source means? the sources which emit the wavefronts which are vibrating in phase, that is vibrating in phase, then those sources are called as coherent sources, right? So this one we have to know. So what are coherent sources? So what are coherent sources means the two sources which are vibrating in same phase, that is in phase, vibrating in phase, then those sources are called as coherent source, right? Here if we draw any perpendicular bisector on this medium by these two sources, then we get the intensity I is equals to 4I0 at any way in this medium. If we draw the perpendicular bisector from S1 and S2, at that point we get the intensity I is equals to 4I0. So this interference is called as constructive interference. So this interference we call as constructive interference because its intensity is increased to that of the initial intensity, that is individual intensities, that is I is equals to 4I0. Here the two sources are interfere constructively. Hence the interference is called as constructive interference. When the condition is the sources or the point which we are considering in the medium is at the same distance from these two sources, then the interference we call as constructive interference, right? So this one is the first case, that is the source, the point P which are considering at the same distance from these two sources, then we get the interference we call as constructive interference, and the resultant displacement is y is equals to 2a cos omega t, and the resultant intensity is I is equals to 4I0, where I0 is the intensity of the individual wave, that is I0 is equals to a square, right? So this is the first case. So in the second case, considering here also considering the two sources S1 and S2. Considering a point, here we are considered the point P somewhere in the medium. Here also we are considering one point somewhere here, that is Q. So somewhere here it is Q. So from source S1 the waves are emitting, and from the source S2 the waves are emitting. So if I write the waves, right? So like this, the two sources or emanates the waves to reach the point Q. So here the Q is the point somewhere in the medium, that is at a certain distance from these two sources S1 and S2. So here if you observe, the source S1 has traveled, if I write, already we know, so the one cycle we call as, so this one is the one cycle. So this cycle, if you write in terms, then it becomes lambda, that is the wavelength. So if you write this waves in terms of wavelength, then it is lambda. If we write in terms of cycle, it is the one cycle and that is equals to 2 pi. That is one cycle is nothing but 2 pi. So if I write here the displacement or the from S1 to S2, the waves which are emanating at, so if I consider here the length of the wave, here the length of the wave, this is for 1 lambda, here it is 2, so here it is 3 and here it is 4. So here the wavelength of the wave is 4 lambda. That is the displacement from S1 to Q. That is the length of the wave is 4 lambda. If in the similar way, if I write for the source S2, here it is 1, 2, 3, 4 and it is 5 lambda. The wavelength of the second wave, that is 5 lambda. So if we write the displacement, that is here, if we observe here means the source S1 reaches one cycle earlier to that of the source S2. That is one cycle nothing but one wavelength. So here the difference is lambda. Here it is 4 lambda and here it is 5 lambda. Here it is in terms of, if we study the waves, here we have 4 waves, that is 4 cycles, and here it is we have 5 cycles. So if we observe here, the waves which are emanating from the source S1 reach the point Q one cycle earlier to that of the source S2, right? So if you understand here, if we studied in case of cycle means the source S1 which emits the waves reach the point Q one cycle earlier to that of S2 because it has to travel one more cycle. Then if we write S2Q minus S1Q, that is equals to, if we write in terms of path length, so 5 lambda is the path length of the source S2 and 4 lambda is the path length of the source S1, then the difference is 5 lambda minus 4 lambda. That is 5 lambda minus 4 lambda. Here S2Q minus S1Q 8 lambda. That is the difference in the path length. So here the difference in the path length is lambda. The waves which emanating from the source S1 and S2 reach the point Q which is also in phase. That is which travels with the in phase. Hence the difference is S2Q minus S1Q, that is equals to the lambda, right? So if we write the displacement of S1 and S2, so here Y1 is the displacement produced by the wave S1, that is equals to A cos omega t, right? Y1 is equals to A cos omega t. Here the wave which reaches earlier, that is S1 reaches earlier to the point Q, that is one cycle earlier to the source S2. If I write the displacement for source Y2 is equals to, so here the wavelength is lambda, so one cycle means the lambda is equals to 2 pi, that is the source S2 delayed by the how much? 2 pi. Then the displacement is y is equals to A cos of omega t minus 2 pi. So we can write the displacement equation for the second wave like this: A cos of omega t minus 2 pi. Minus 2 pi means because it delays by the cycle 2 pi. That is one cycle it is delayed. That's why we are taking minus. That is cos of 2 pi minus theta. That is cos of minus theta can be written as cos theta, and cos of 2 pi minus theta can written as cos theta. So the equation y2 becomes a cos of omega t. So if you observe, the equation y1 is equals to the equation y2. So this indicates means the source which are producing from S1, that is waves which are producing from the source S1 is equals to the source which are producing, that is waves which are producing from S2. So these two are in phase, that is in phase, that is these two sources are vibrating with the constant phase, hence we get the displacement equation same. Hence if we write the resultant displacement, then y is equals to y1 plus y2, that is a cos omega t plus a cos omega t, we get 2a cos omega t. So this is the resultant displacement for the second case. If we study as case 1 and case 2, so this is the case 1, here is the case 2. In the case 2, what happens? Here the distance that is from S1 to Q is not equal to S2 Q. S1 Q is not equal to S2 Q. Right? So here we get the displacement y is equals to 2a cos theta, similar to that we get in the first case. Then here also if we write for the resultant intensity, that is square of the amplitude, then we get 4a square, then we get right in terms I is equals to 4 I naught. Right? So here I is equals to 4 I naught. I naught is the intensity of the individual wave. That is I is equals to a square. So I naught is equals to a square. Right? So by observing these two, we can say that here the two sources are interfere constructively. Here also we get constructive interference. Here also we get the constructive interference because here the intensity is same, that is I is equals to 4 I naught, and the resultant displacement we get is 2a cos omega t. This is for the second case. Here the second case we are taken S1 cube is not equal to S2 cube. By observing here the source S1 which produces the waves which travel one cycle earlier to that of the source S2. So here we have 4 cycles and here we have 5 cycles. So one cycle is nothing but 2 pi. If we write in terms of wavelength, it is lambda. So here we get 4 lambda and here we have 5 lambda. Then the difference, part difference is S2 cube minus S1 cube, that is 5 lambda minus 4 lambda, we get lambda. So 1 lambda is equals to 2 pi. Here the source S2 wave delays by 1 lambda, that is delays nothing but later after reaching of S1, the S2 will reach the source Q by the length lambda, that is one wave, that is one cycle. That pi we are going to take here minus 2 pi. So minus 2 pi represents what means delays. The source S2 delays by one cycle. That's why we are taken as minus 2 pi. So this is the second case. So we have to understand this one. So in the second case also we get the constructive interference when the source S1 reaches the point Q earlier that of the S2, right? So move on to the next case, that is third case. So here what happens? In the first case and the second case we get the constructive interference. So this is very important. In the main exam, they ask for 5 marks. Give the theory of the interference. That is, it is very simple. They ask for the 5 marks for the give the theory of interference. So in the next case, that is case 3. So here also taking two sources S1 and S2. So somewhere here in the medium I am considering PQ and here it is R. So if I draw the waves from here to here, it is right. So this one is the point R. If I observe here, we have the waves that is emanating from the source S1 and S2. So here how much cycles that travels, that is S1, here it is 1, 2, 3, 4, 5, and here is the half cycle. So half is 0.5, then we can write 5.5 lambda. Half is 5.5, that is 5. If we observe here, if we consider this one as the full wave, that is for one cycle, so we have half year, so this one can be written as half cycle, that is half lambda. So here we can write half lambda, then we get, if we added these two, we get the full wavelength, that is lambda. Here we have remaining only the half cycle, that's why I am going to consider here 5.5 lambda, right? So this is the source S1. The waves emitting from the source S1. So if we check for the source S2, then here it is 1, 2, 3, and here is 4 lambda. Right? So if we observe here, the source S1 which emits the wave, it travels, that is the waves which are emitting from the source S1 reaches, difference is how much? 4 and 5.5 is 1.5, that is 1.5 cycle later to that of the source S2. If we observe here, the source S2 reaches earlier because it travels only the 4 cycles, but the source S1 has to travel 5.5 cycle, that is the difference is 1.5 cycle. That's why the source S1 travel 1.5 cycle later, that is it has delayed 1.5 cycle to that of the source S2. So if we observe here, the S2 have 4 lambda and S1 has 5.5 lambda. So if we write the path difference, then S2R minus S1R, that is equals to 4 lambda minus 5.5 lambda, that is equals to minus 1.5 lambda. Right? In the second case, we observe the lambda is 1, that is the difference is 1 lambda. Here we get the difference is 1.5 cycle, that is 1.5 lambda. If we write in terms of the wavelength, then if we draw that is if you write the displacement for these two sources, then considering as is the displacement produced by the source S1, that is y1 is equals to a sine a cos omega t. So a cos omega t. If we write for the second one y2, so here we are observing here means 1 lambda is equals to how much? The difference in terms of cycle means 2 pi. Here we have 1.5 lambda, that is 1.5 lambda. So 1 lambda is 2, then 1.5 lambda is we get 3 pi. So here we are writing for the second one, that is for the source S2, which reaches earlier that of the source S1, right? So if you observe here, it travels only the 4 cycles. Here it travels 5.5 cycles, that is S2 reaches earlier. How much earlier? That is 3 pi. If we write in terms of cycles, that is 3 cycles earlier to that of the source S1. Then we can write y2 is equals to a cos of omega t. Earlier means plus. Here how much delayed? So here minus we are going to take means the source S2 is delayed by the 1 cycle. Here the source S2 is earlier to that of source S1. How much cycle? That is 1.5 cycle. So 1.5 cycle can be written as 3 pi. That is omega t plus 3 pi. Right? So we can write y1 is equals to a cos omega t, y2 is equals to a cos of omega t plus 3 pi. So plus represents it reaches, y2 reaches earlier. Here minus represents y2 reaches later that of y1. So if we know cos of 3 pi is nothing but pi. So 2 pi is 1 cycle, then the cos value will be in the third quadrant, right? So in the third quadrant, the cos value is negative. So cos of 180 plus omega t, then we can write minus a cos omega t. So this is from the trigonometry, right? So 2 pi means 360 degree, 3 pi means 360 plus 180. So 180 after 180, that is 180 plus theta, that goes to the third quadrant. So in the third quadrant the cos value is minus, hence we can write y2 is equals to minus a cos omega t. So if we observe y1 is in positive and y2 is negative, that is these two waves are out of phase. So in the previous case we discussed here these two are in phase because y1 is equals to y2, hence these two waves are in phase. Here if you observe y1 is in positive and y2 is in negative, that is out of phase. So y1 and y2 are out of phase. Then if we write the resultant displacement, y is equals to y1 plus y2, that is a cos omega t plus of minus a cos omega t, plus into minus the terms of same, then y is equals to 0. The resultant displacement is 0, and if we write for the intensity for the resultant displacement, then we get I is equals to 0. So if the intensity is 0, that is these two waves interfere destructively, that is opposite. Here we have constructive, that is adding up of the waves. Here it is destructive, hence the interference we call as destructive interference. So understand here the displacement y is equals to 0 in case of the destructive interference. In case of constructive interference, we have maximum intensity. So this one is 4 I naught. So here in the destructive interference, we have minimum intensity, that is I is equals to 0. So the resultant displacement y is equals to 0. So understand this one. That is for the case 3. Here also S2R is not equals to S1R because it is certain distance from the R, then the two waves are out of phase, that is which is not equals to in phase, right? They are vibrating in the opposite to one another, hence we get the resultant displacement as 0. Then this one we call as destructive interference, right? So this is about the theory of the interference. So how we get constructive interference and how we get the destructive interference, right? So if we write in the general forms, we can write in two methods. So one is path difference and another one is phase difference. So if pi is taken as the phase difference between two waves, then what happens then? If we consider the path difference as lambda, so what happens? So in general, S1, S2 are the two coherent sources producing the waves of displacement. So if we write in general, we can write S1 and S2 are coherent sources for a point P anywhere in the medium. Point P, here we consider P, Q and R. In general, we consider any point P anywhere in the medium, then the displacement y1 and y2, if we write in terms of that is in terms of if we write in terms of path difference, we can write y is equals to n lambda. So this is the resultant displacement. This resultant displacement is equals to n lambda, where n is the integer value, that is n varies from 0, 1, 2, 3 like this. Then lambda is the wavelength, where lambda is the wave length. Then y is equals to n lambda, and for this one is for constructive interference, right? So this is for the constructive interference. So if we get n is equals to 0, that is the resultant displacement is, so here it is from 1 lambda, 2 lambda, so n is equals to 1, 2, 3 and so on. So if we get n is equals to 1, 2, 3, then we get here is the constructive interference. So this is for the constructive interference. Y is equals to n lambda. Here n is the integer value, where lambda is the wavelength. So if we write for destructive interference, that is y is equals to n plus 1 by 2 into lambda. So that is here n values varies from 0, 1, 2, like this. So here the lambda is same, then here it gives destructive interference. So if we write the intensities here for the constructive interference, then I is equals to 4 I naught. So if we write for the destructive interference, the intensity I is equals to 0. Right? So this is the relation if we write in terms of path difference. So here lambda is the path difference, that is the wavelength. N is the integer value. Here n is the integer value. So n plus 1 by 2 into lambda. So for this relation, we get the destructive interference and the intensity is 0. Right? So in the previous we studied that 1.5 lambda. If we put here n value 1, then it goes to 3 by 2. That is, we get 1.5 lambda. So if we put 2, then it becomes 5 by 2. That is 2.5 lambda. Then also we get the destructive interference. So this is the interference if S1 and S2 are the coherent sources for a point P anywhere in the medium, then if we write in terms of path difference, y is equals to n lambda for constructive interference and y is equals to n plus 1 by 2 lambda. This is for the destructive interference. So in the next class, we will discuss in terms of phase difference and what happens in incoherent sources. So this is for coherent sources. So what's the intensity and what's the relation? So in the next class, we discuss the interference in terms of phase difference. So here we discuss in terms of path difference. In the next class, we discuss in terms of phase difference and for what happens for the incoherent sources. Thank you.